You guys ready?
No.
Alright, so in this course we're going to be learning about networking and things like that. But okay, so when it comes to networks, we're going to be learning about different types of networks. So in networks, there's LAN networks, there's WAN networks, and with a LAN network, it's your network here locally, as you can tell by the name, local area network. So these are all devices connected through a wired connection, and you could think of it as like if this device, this laptop, was connected to your laptop wiredly, that's a LAN connection. That would be your LAN network. And the second one is the WAN, which is your wide area network. And you can think of it as like this school building connecting to the internet. We have all these wireless and connected devices, and they're being exported out into the internet to other networks. And you can also see it by representing like this. So we'll have our server, we'll have our database, we'll have the device connected locally, and it's connected to this other LAN network through the WAN interface, through this cloud. So the reason why we actually do that is because back in the day, in like the 1970s, somebody wanted to be able to connect to a different device, like your computer or a different kind of computer, and send data to that. But obviously they couldn't figure out the way, or it would be difficult, like they'll have to send the files on some, I don't know what they had in the 1960s, but some drive, of course. So we'll do this to have it a way to make it easier to transfer files and to create local sessions. Another network type is a VPN. Does anybody know what a VPN is?
Virtual private network.
Yes, and what is a virtual private network?
It basically sends your IP and it sends you all your information to a different server, and that's what shows up as who you are, and then it encrypts your data and sends it to someone else.
Yes, so basically it encrypts your data, encrypts you, the user, and by changing your IP address, so that when people try to find what kind of device was actually connected to their local session, they would get something that is different, something that's spoofed, right? It won't be what's your original. It's basically like having a mask, right? If you have a mask, you're not going to know who's underneath that mask. Some other different types of networks that we really don't want to get into because it's not necessary for our work is a MAN and a PAN, personal area network, and metropolitan area network. So with a personal area network, you'll have these networks connected through like different organizations, right? It'll be like from one stationary point to another stationary point, and they're connected to each other. And with a with a MAN, right? You'll have networks connected through a city. So if you had a city like Springfield, they're connected by a MAN with all their local networks. Okay, now does anybody know what an IP address is? And the two different types?
IPv4 and IPv6.
IPv4 and IPv6. So what is an IP4? An IP4 is an IP address represented as 32 bits that is separated in 4-bit octets, each octet having 8 bits. So most of you guys might be familiar with this kind of format, though, with 185.107.80.231, right? That is going to be your IP4 address. That's how that is formatted. And the amount of addresses is based on how big your bit size is. So if I have an IP4 and it's 32 bits, I have 2 up to the 32nd amount of addresses, which is about 4 trillion. The second one is the IPv6, and that's addressed by 128-bit addresses, separated by 16 8-bit octets, and the formatting is a little bit different, as you can see on the left side. So on the left side, each octet is separated by colons, and you can even decrease the size of your IPv6 address with any zeros you have at the end. So zeros at the end can be omitted into 2 colon spaces. I know Sam might know this from doing stuff at SRTC, but with you, it's going to be a little bit new. So with IPv6 addresses, they're represented as hex. Now, does anybody remember what hex values were?
Yeah.
So remember,
like 0x, 01, something like that.
0x, wait, what? 0x? Yeah, 0x, and of course, what was the other?
Like A1, A2, all that.
What? Oh my goodness, what is this?
01.
So
0x01 or 0x10.
yes, so represent as 0x01, right? As that kind of format, or 01 to represent the same thing. So 0x01 is also equal to 01, of course. Okay, but what was the values? So it was, you know, we had ones.
The letter is 10, and then the values.
What value was 10?
A.
A. So A through what though?
F.
A through F. So obviously they're represented as differently, and we're able to get more hosts and addresses with this. With an IPv6, we're able to get 128-bit addresses, which 2 to the 128th is significantly higher than 2 to the 32nd, right? So differences between TCP and UDP. So TCP stands for Transmission Control Protocol, and it's used to connect users and servers and receivers with a wired connection, used to transfer data really quick, reliably, but not quickly. And with UDP, it's able to connect to servers and to hosts with a wireless connection. It's very fast, but not reliable. And usually you have TCP for doing emails or sending files, and with TCP you'll do it for gaming or for streaming. Not really a whole lot you have to know about that kind of stuff, but it just gives you a general idea of how this network, of how networks in the real world works. So with networks, there comes protocols and ports. Yeah. I'm not going to have you guys remember these. I don't even expect you guys to remember these because there's too many out there. And honestly, I've actually posted a cheat sheet on Discord that shows you guys what all these ports and protocols are on. So as we can see, on port number 20 and 21 is represented by FTP, which stands for File Transfer Protocol. This is how we're able to transfer files and other things, file related, from host to host. We also have SSH on port 22, Telnet on 23, so on and so forth. Okay, last few things before we start actually doing, some practice challenges and things like that is encapsulating data. So when you're encapsulating data and sending it to a destination, right, it first needs to, usually it gets encapsulated, which means that some data or some files are being put inside your packets, which your packets are your data, before it gets sent to your destination. So let's say, for instance, I sent Braden an email, right? And the email was unencrypted. Well, encapsulation will then take that packet, take the email, before it gets sent to the destination and add some encryption to it. And that's to ensure that if there was someone else to receive that email without actually getting to Braden first, they won't know the contents of it. And decapsulation is when the receiver, Braden's Gmail, for instance, will be able to decrypt that message before it reaches to Braden's message catalog. Okay, we can also see some of this encapsulation and decapsulation inside of this little diagram here. So from the top, we have our application, which is our computer. It sends data to this network media, and before it sends data, it's going to go through these sessions. It's going to encrypt the data. It's going to send some headers, some IP, additional information to know where that information came from. It's also going to decrypt it at the very end before it reaches its destination. So a little video I want to show you guys is something that explains these networks and these protocols probably a lot better than what I'm doing right now. But Network Chuck, has anyone seen Network Chuck on Discord? Yeah, he's pretty good. He has a lot of speeches over these network configuration.
This is
We're just going to do it
of my
like this.
free CCNA course in a huge CCNA, CCNP labs. Do that.
There you go.
Well, it's simple, right? I clicked shoot and the computer shut, and that's what happened. But hold on a second though. I'm playing online, and the guy I shot isn't just in the game, he's actually playing a game somewhere far away from me. How did my bullet get all the way to him? Actually, come here with me real quick. Okay.
Does anyone hear that?
That bullet has to fly over this Ethernet cable all the way down here. Come on, let's go down here. It goes into my wall jack here. Come on, let's go. It goes into my IDF, to my network stuff here in my rack. Comes through my walls, to my switch, to my router and firewall, then to my modem. And where does that go? Come on, come on. Goes to my AT&T fiber box, and then to the internet. Okay, the internet. You probably saw that coming, right? Like, duh, Chuck would play online on the internet and would play Call of Duty with other people. But what happens after that? When I fire that bullet, where else does it go? I've already shown you how it goes through your entire network. This is what you have right now. If you're playing Call of Duty online, this is your local area network. What happens when we go outside your home to the WAN or the wide area network? Let's see. And the internet will just be more routers, just someone else's routers, hip hopping across great distances. And that's all the internet really is, just a bunch of routers connected. But of course, it's not just routers. You'll have switches here, firewalls, just all kinds of stuff in all these different networks. But the cool thing is that in the blink of an eye, as fast as you can fire a bullet in Call of Duty, that's how fast things are going across all these routers. Until finally your bullet flies all the way to the Call of Duty servers. But hold on, not finally, not yet, because your bullet has made it to Call of Duty, but now Call of Duty has to send your bullet to the guy who's about to get shot. So, again, we go back up to the internet. Bam, back to the router. This could be another path, hopping from router to router to router, until it finally arrives at my brother's house. Because he is the one I shot, and it will hit his modem, his router, his switch, travel through his Ethernet cable to his PS4, and he gets shot. Now, why did I show you this? Why would I show you how a bullet can travel across the internet? Well, I did it as a test. What I'm hoping is that if you saw this, you would go, wow, I want to know more about how that works. I want to do something like that. If that was you, this course is for you. The CCNA is for you. Because what I just showed you is what you'll be learning in the CCNA. Networking, how networks work. Now, if you look at this, the networking we have now is pretty complex, but the goal is the same as it was 20, 30, 40 years ago. I want my computer to talk to another computer. I want to share data with that computer. I want to hang out. That's all we want to do. And that's how networks came about. It was one computer saying, hey, I have all this data I want to share with another computer, and I can't do that right now without a lot of effort. So, you know what? Let's figure out a way to connect ourselves. And that's where networking was born. We can still do this, by the way. You can use an Ethernet crossover cable just to connect two computers together. But Mark, he wanted to talk too. Mark over here was left out in the cold. Oh, hi, Mark. So in comes switches. And a switch will allow us to connect more than one computer together. Doesn't have to be a computer, it can be a printer. Oh, by the way, just so you know, I'm glossing over this. There's a lot more involved. Broadcast domains, MAC addresses, VLANs, all kinds of stuff with switching. So just know, this is just the tip of the iceberg. But if you like this, you'll like the other stuff too. Now this is a network, and a switch facilitates that. All these computers are connected together, they're inter-networked together, and they are having a blast talking to each other, playing games, whatever. Now a switch can only handle so much before there are too many computers talking, too many things talking all at once, and he's like, I can't do this. So what do? Well, we get another switch. Easy enough, right? So easy. And we connect more computers, and they have a blast, they're having a good time. Yes, and yes, the more computers I draw, the worse they get. You probably can't even tell they're computers anymore. Well, I should probably label my switches, right? Let's just call them switches, so you know what's going on. Now what we have here is essentially two networks. Let's call this network 1 and network 2. We got a problem though. What if Bob over here wants to play a game with Mark, but they're not connected together? How do we solve that problem? Well, that's where routers come in. Routers. I'm not going to draw one, I'm just going to bring one in. A router will help these two networks talk. That's what routers do. They help networks talk to each other. So we connect our switch up to our router. Bam, bam. And a high-level view, extremely high-level view of how this might work is Bob's like, hey, I want to talk to Mark. So he says, Mark, are you here? And Everyone's like, no, Mark's not here. So Bob's like, well, maybe he's over here. So he goes to the router and says, hey, router, is Mark anywhere? Do you know about Mark? And the router's like, yeah, I think I might know where he is. Bam. Hey, Mark is over here. And now Mark and Bob can talk to each other. So where does the internet come in? Well, this might be just one section of the internet. So we'll put them down here, and we might have another router with another situation. And by situation, I mean another switch with a bunch of computers who just want to hang out with people and talk and play games. And we connect these two routers together. And the internet is just this times 1,000. Now again, I've got to say this. If you were to pop the hood on the internet and look inside, it's pretty complex. Like, there's a lot of stuff going on. So keep in mind what I'm saying here is very high level, but that should be exciting to you. Like, wow, I can't wait to learn more about how all this works. And we'll definitely cover that. Okay, so we looked at our switch and we looked at our router. What about this guy? What's a firewall doing? Well, simply, he's protecting you. He's protecting your network. Now, as you may know, there are some bad people out there, some bad dudes that want to attack your network, that want to steal your information. These hackers are constantly trying to find ways to steal your stuff. And while they'll try to get into your network, a good firewall will keep them out. Now, again, with networking, routers and switches, we want to connect people, connect computers, connect devices, smartphones and smart lights and all kinds of stuff. And that's normally good. But then there's bad things, and that's where a firewall comes in. A firewall's job is to block anything that shouldn't come through or go out, and only allow the good stuff. Now, I'm hoping at this point, some of you are probably going, Chuck, I don't connect anything to a switch in my house. There's no cables anywhere. What are you talking about? Well, you're right. For the most part, most of the things we use in our networks have no cables. And that's why part of the CCNA, you'll learn about wireless. But what is...
Okay, that's the end for that. So with what he was saying is that everything's connected through a wireless or wired connection. And that's basically how the internet runs. Okay, so everyone pull up your Chromebooks and go to the terminal real quick. There's a few commands when it comes to talking and interacting with the network and hosted services and host services served on the network. So does everybody knows the ping command, right? Ping command, ping, you can ping a host, ping some IP addresses. So if I want to ping a domain like google.com, it will show me what is hosted on google.com. Press Control-C to stop that pinging. And even when pinging a domain, we can get the IP address of that domain. So with that, we're able to test our connection. We're able to test whether or not we are able to connect to a domain, connect to a host. And if we want to see if we can connect to a host like 172.16.1.0, we can ping it and see if a connection even gets sprung up. If not, you might get an error message, or you're not going to get any, or it's going to say destination host unreachable. So another command to check your IP, you can run the command config, if config, and we'll see we have these three sections. We have ETH0, LO, and WAN0. So ETH is going to be your Ethernet. If you had an Ethernet connected to your device, you would have that IP address. LO stands for loopback. Runtime is going to be testing your broadcast, testing your gateway between you and whatever you're connected to. And your WAN is going to be your wireless connection, in this case, your wireless connection. And you're going to be assigned your IP address, which is INET, and that one right there. Now you can also see your IPv6 IP address through this line right there as well. So another thing that you might want to also know when it comes to Nmap is the -sn command, which specifies what kind of ports you want to specify. So let's say, for instance, we wanted to do Google. Let's do Google instead. Okay, so everyone type in the command nmap-sn, right? Google.com, or well, you might have to get the IP address. So everyone do ping google.com to get the IP address.
I think it's 172.2,
Yeah, 172.217.28.110. So we'll do nmap-sn 172.217.28.10. And what you want to do after that is specify a subnet. We're going to talk about subnets later, but we're going to look through all of Google's hosts hosted on google.com. So we'll do 24, as that's basically the default is 24 for default gateways and stuff like that. So we'll do enter. And as we can see a lot of hosts that Google.com has. We have 172.217.28.255 and it keeps going. So one thing I forgot to mention is how many hosts can be on one octet of an IP4 address? 256. 256, yes, okay. Alright, so when it comes to subnet masking, there's a lot of things that it comes with it. There's, whenever you specify a IP4 address and have a subnet, it lists from this one specified port to another specified port. So let's say, for instance, go in here, right? And I had the IP address like 172.116.1. So for instance 0, and we had subnet mask 24. Well, that's a list range of IP addresses. This together is like 172.116.1.0 to some address, right? We'll have to calculate it to actually see what kind of address that ends off to, most likely 255, but you get the point of that. So this guy illustrates what this kind of subnet masking is and how we can actually use it to specify our kind of hosts.
Managing something as big as the internet is no small undertaking. The internet is huge, comprising millions of networks. To make communication feasible, subnets break large networks into smaller, more manageable networks that run more efficiently. Each subnet is a logical subdivision of the bigger network. Connected devices within a subnet share a common IP address identifier, enabling them to communicate with each other. Routers manage communication between subnets. The size of the subnet depends on the connectivity requirements and the network technology used. An organization is responsible for determining its number and size of the subnets within the limits of address space available, and the details remain local to that organization. Subnets can also be segmented into even smaller subnets for things like point-to-point links or for subnetworks supporting a few devices. Among other advantages, segmenting large networks into subnets enables IP address reallocation and relieves network congestion, streamlining network communication and fueling efficiency. Subnets also improve network security. If a section of a network is compromised, it can be quarantined, making it difficult for trespassers to move around the larger network.
So the main points you probably have to take from that is that you're able to categorize your network in certain sections and to also have more of a range of your IP and hosts. So we talked about stuff like memory allocation and things like that. Most of you guys might not have to learn about that here, like right now, but just keep that in thought. Anyway, so this is another subnet, this is another cheat sheet, which specifies all these subnets, subnet masks. And we can see from subnet 30 all the way down to subnet either 0 or 1, I'm not sure which one it is. But we're able to see what each net mask will be categorized. So 30 is that net mask, and 28 is that one, and so on and so forth. And we can see that 24 is 25.25.255.0. And to actually calculate what kind of range an IP address and a subnet mask has, we can look up like a subnet mask calculator.
Accumulations.
Yes. So what this is going to specify is going to specify our network class. And our network class is dependent on what our subnet mask is going to be, whether that's going to be /30 or /24 or stuff like that. Usually a typical network is going to use class B, and let's use subnet mask 24 for instance. And if we were to use the IP address 172.16.1.0 for instance, we can see that the network address first starts at 172.16.1.0, and the usable hosts in this range is from 1 to 254. So in total, we have 254 usable hosts. where our broadcast is 256, or no, 255, sorry. Yeah. Okay, so we're going to hack the box now. All right, everyone go back to hack the box. Okay, so the first task it asks us is what TCP, or which TCP port is open on the machine. You guys remember what command we need to use to find that out?
I'm tired. Your mom.
Not true. Alright, what command do we have to use? No, Sam, don't answer this.
Nmap.
Nmap, good, okay. So we'll do nmap,
VPN.
and then the IP address.
Yeah, that word.
Now, with this, you're going to have to run a parameter, alright? Because we don't know which port is open on this IP. So what parameter do we do to specify a port? You guys remember? What?
-P.
Dash P. And when we do -P dash, it specifies all ports. It specifies nmap to run all ports on the IP. So I'll do nmap -P dash, and then my IP address. So I'm going to press enter. But what can we see here on the board? What service is it running on?
Redis.
Redis, okay. And then, what type of database is Redis? From the following options, I can just tell you right here, right now, it's option 1, which is an in-memory database. And an in-memory database is when your storage, your local storage of how the service is running on, is stored locally on your memory. Okay, so next thing is, which command line utility is used to interact with the Redis server? Enter the program name, you would enter it in the terminal without any arguments. So for this one, we'll have to probably look that up, because even I don't know that. And I believe this is a Windows service. No, it's a Linux service, so a service that I've never used before. So you do Redis-CLI, and CLI stands for client. Okay, so which flag is used with the Redis command line utility to specify the host? Obviously, you can run Redis-CLI --help. So --help is the parameter of the command. Okay.
Strangle my computer.
So let's do Redis-CLI, alright, -- or parameter help. And we can see a lot of these functions.
And I need to install Redis.
Yes, you might have to install that. And I can tell you from the first option labeled here, what is it? What's the first option labeled here?
Parameter age, server host name.
Yes, so host name. So that's how we specify the host name using Redis-CLI. So yes, -h to specify our host. Once connected to a Redis server, which command is used to obtain the information and statistics about the Redis server?
CD.
All right, how about this? Let's first connect to the service. Remember? So let's do Redis-CLI sh, and then I'm assuming the IP. All right, so right now we're in there. So I wouldn't know what command it is because, like I said, I haven't used Redis client before. So we'll use our resources, the internet. You know it, but obviously you won't answer it, right? So everyone copy the question, right? And we'll want to look up online to figure out which command it is. And which command is it to specify our information on the service?
The command.
Info command.
Info, there we go. Okay, so the command is the info command. And that's how we can see some information on the server. So now, what we want to do is we want to see what the version of the Redis is used on the target machine. So we'll go back real quick. And we'll want to see what version it's running on. What version is this Redis server running on? Okay, so now do info. Very good. Okay, now when you do it, what do you see after that? What's the service session version? It'll be
5.0.7.
boom, 5.0.7. Okay, next test. Which command is used to select the desired database in Redis?
Command. That.
Would tell you that's too easy.
Does anybody know which command is used to select the desired database in Redis?
Select.
select. I'm assuming you're correct, which you are. So select. You also could have looked it up online to find out which command that was.
You could also believe
4.
Good job, Brady.
4.
How many keys are present inside the database with index 0? And how did you find that out?
I guessed until I got it.
I mean, you can really just brute force that.
You
I
brute
mean, yeah,
force
you
it.
could definitely brute force that, yeah.
But
Which
also, if you go to the
command
very bottom,
is
I'll go to the very
used
bottom,
to-
it'll have keys equal 4.
Get all the keys.
Yes, you are right.
What?
I would
At
get all
index
the keys.
0. At
gotta
index
get
0, as
all
you
the
can see all the way right here.
Give.
Database 0.
Database 0 has
DB
4.
stands for database.
I would like keys, please. We need all the keys.
Hammond, how many keys is inside that database?
4.
4, there we go. Okay.
Boom.
Which command is used to obtain all the keys in a database?
Ooh. I know this.
Obviously, if you don't know, just look it up.
I figured
That's what
it
the
out.
Master key.
That is
I
not the
figured
answer.
it.
No, however, this command here, that ampersand sign, no, not the asterisk sign, that is what we call a wildcard. That selects everything that comes after a certain command. So,
So I was close.
what did you say?
Master key.
Yeah, master key. Basically, it gets everything, you know what I'm saying?
Yeah.
However, we need to specify a command before that. So, what command would that be?
Keys.
Yeah, makes sense, right?
Yeah. Keys, asterisks, shows you all the keys.
Keys.
Define.
Boom.
I typed it in and it said error, connection timed out.
Hate
Bro's on a free trial.
Bro, I did it. I did it. Let's go.
Okay, now how do we get
There.
a key?
You put get and then the key you want.
Makes sense, right? So we'll get flag, right? And we have the specified flag.
And
Copied it?
Copy and paste it.
Boom, perfect.